Hey guys, so in this video we're going to be looking at multiplying polynomials with the box method. So I've got some steps on the screen and these come straight out of your notes. But when we're multiplying, I teach using the box method. So the first thing we need to do is set up our box. The length is going to be the number of terms. And remember, terms are separated by addition or subtraction signs. So the length is going to be the number of terms in the first polynomial. Width is going to be the number of terms in the second polynomial. Truly, the order on that doesn't matter. I just say the length is the first, width is the second to kind of streamline it some. You then want to label your box. First polynomial down the side, second polynomial across the top, and then multiply to fill in the box. So we're going to multiply to fill in the box, and then add once the box is filled in to combine up any like terms inside the box. Make sure that all your answers are in standard form, and that means that your exponents are decreasing. Step 5 is just kind of a check. Make sure that you're in the correct form, but really steps 1 through 4 are the actual box method. So, and I have on here the product rule just to remind you from the previous sections. Product rule said that if you have two big bases being multiplied, that I can add the exponents. We're going to use that a lot in this section. So let's look at the first example. So example 1, I have 4x squared y times, now I don't see that, but that means times 9x to the third y. A lot of times students get confused terms and variables. Yes, these each parentheses has two variables, but it only has one term. That whole thing is one term, 4x squared y. And then over here, 9x to the third y, that is also one term. What it would look like if it was two terms and two terms is this problem. Notice how I have that addition sign to make this one term, two terms, one term, two terms. So this one would be a 2 by 2. All right, so over here I've got a 1 by 1. So I set up a 1 by 1 box. You don't really have to do box method for this one because it's pretty straightforward, but you still can. So I've got 4x squared y along the side and 9x to the third y along the top. And then to fill in the box, I'm just going to multiply. I'm going to multiply my numbers. 9 times 4 is going to give me 36. Multiply my like bases, x to the third, x squared. Well, x to the third times x squared, that is a product rule, which says that I'm going to add my exponents. And then the last one, y times y. Well, that's y to the 1 times y to the 1. Or add those exponents and get y squared. Now there's no like terms that I can combine because there are no other terms. So my final answer would be 36 x to the fifth y squared. And that's it. All right, let's look at example 2. So, or it's 3 because I have an example 2 over there we're going to come back at. So next example, 5x plus 2, 3x plus 2. I am multiplying those. I don't see a time stop, but that is assumed multiplication. This is a 2 by 2 because I have one term, two terms, one term, two terms. So I'm going to set up a 2 by 2 box. First polynomial is going to go down the side. 5x plus 2. And second polynomial, 3x plus 2 is going to go across the top. Now when I fill in the box, I'm going to multiply. I'm going to multiply the top by the left. So if I'm filling in this first square, 3x times 5x. Well, 3 times 5 gives me 15. And then x times x, well, that's x to the 1, x to the 1. So 1 plus 1 gives me x squared. Okay, I'm going to go over 2 times 5x. Well, 2 times 5 gives me 10, and then x. Next one, 3x times 2. Well, 3 times 2 gives me 6x. And then the last one, 2 times 2 is going to give me 4. Anytime we don't see a sign of a number, it's assumed positive. So all of these are positive 15x squared, positive 10x, positive 6x, positive 4x. Now that I've multiplied, now I'm looking to combine any like terms. So this goes back to the last section where we were learning to add and subtract polynomials. Like terms have to match in variable and an exponent. And I do actually have some like terms. I've got like terms with the 10x. Oops, I made that whole thing go away. 10x and 6x. Those I can add. 10x plus 6x is going to give me 16x. And then I'm going to carry all my other terms around. 15 squared, 15x squared, I'm going to keep up front. And then that 4, I'm going to leave in the back. Because remember, I want it in standard form where my exponents are decreasing. And so that would be my final answer. So I fill in the box by multiplying. Once the box is filled in, then I add up the like terms, if there are any, and then that's my final answer. All right, let's look at this one. X squared plus 9x minus 7 times negative x. Well, I have 1, 2, 3 terms by 1 term. And so I set up a 3 by 1 box. So I'm going to have my x squared plus 9x minus 7 down the side. Each term gets its own spot. And my negative x on the top. And I'm just going to go through and multiply. X squared times negative x is going to give me negative x to the third. 9x times negative x is going to give me negative 9x squared. And then negative 7 times negative x is going to give me positive 7x. Now when I'm looking inside, I don't have any like terms because I have an x to the third, an x squared, and just a plain old x. And so what that means is they are all going to be in my answer, negative x to the third minus 9x squared plus 7x. Got it squeezed over in the corner. And so that would be my answer. Negative x to the third minus 9x squared plus 7x. So here's a little bit of a challenge problem because I wanted to show you the difference between when it's a monomial times a monomial and a binomial. I want you to pause the video and try this one. It's got several variables, but I want you to pause it and try it. And if you get stuck, I'm going to show you the answer just here in a second. All right, so here's how you should have set your box up. Should have multiplied to fill all of those in. Once you've multiplied, there are no like terms to combine. And so my final answer is just all of those numbers together.